at AP Review. This is 2019 BC Free Response 5. Consider the family of functions f of x equals 1 over the quantity x squared minus 2x plus k, where k is a constant. Part A, find the value of k for k greater than 0, such that the slope of the line tangent to the graph of f at x equals 0 is a 6. Cool. So what that's saying, right? Tangent slope at x equals 0 is supposed to be a 6. That's saying f prime of 0 is 6. So my job is to find f prime, then plug in x is 0, and set that whole quantity equal to 6. So I would suggest that when you go to do this, it's easier, rather than doing a quotient rule, I mean, you can do a quotient rule, but I'm just going to do a chain rule and say that it's this whole thing to the negative first. So my f prime of x should be -1, this whole thing to the negative second, times the derivative of the inside, which is a 2x minus 2. So if I clean that up, that's a -1 times this 2x minus 2 on the top, and on the bottom I have an x squared minus a 2x plus a k, quantity squared. So f prime of 0 would be a positive 2, right, because it'd be a -1 times the negative 2, over 0 plus k, quantity squared, meaning my f prime of 0 is a 2 over k squared. So I want 2 over k squared to equal a 6. That means 2 equals 6k squared. So 1/3 is my k squared, and I get that k is plus or minus the square root of 1/3, but they said k is greater than 0, so my k is the square root of 1/3, or if you like it better, 1 over root 3, or if you want to go really fancy, root 3 over 3. Any of those are fine, right? But the thing to be cautious about is if you simplify, you run the risk of doing something dumb, so I would suggest that you either leave it with this answer or this answer and not bother to rationalize. Cool. Part B. I do not need part A for part B. All right, part B. For k equals -8, find the value of the integral from 1 to 0 of f of x dx. Cool. So, part B, I now have a very specific function where this is a -8. So I'm integrating from, and I said 1 to 0 because apparently dyscalculia is a thing. I meant 0 to 1. I want to integrate this thing from 0 to 1. So this is going to be integration by partial fractions. It's not u sub, because if I used u as the entire bottom, my du would be a 2x minus 2, which I just don't have. The bottom factors into an x minus 4 and an x plus 2. If you have a polynomial in your denominator that factors, that's pretty much textbook partial fractions. So I'm going to do my partial fractions decomposition over here. You can do it all in one blow if you want to keep it inside your integral, but I think you run the risk of doing some silly stuff. So I'm going to do the decomposition separately so that I don't have to worry about forgetting my bounds or forgetting my dx. So I'm going to decompose this thing, right, into an a over x minus 4 plus a b over x plus 2, right? Sorry, moving that guy so you can see a little better. So when I get a common denominator on this side, I'm going to times this fraction by the x plus 2 over x plus 2. And I'm going to times this fraction by the x minus 4 over the x minus 4. So what's going to end up happening is, because the denominators are the same, right, they're all the same common denominator, I can essentially, logically it feels like we're just ignoring them. What you're actually mathematically doing is multiplying the entire equations by that quantity x minus 4 times x plus 2, and it just knocks out the denominators. So I get 1 equals a times the quantity x plus 2 plus b times the quantity x minus 4. I do some clever substitution. I choose the x values that will, since this expression has to be true for every x value ever, I choose x's that will conveniently knock out one of the constants that I need. So I choose x is -2 to knock out this guy, and what happens is I get 1 equals a bunch of 0 plus a b times a -6, so -1/6 must be my b. I choose x equals 4 to knock out this guy, and when I do that, I get 1 equals a times 6 plus a bunch of 0, so my a is a positive 1/6. So I come back over here and say that what I'm really integrating is from 0 to 1 of a 1/6 over x minus 4 plus a -1/6 over an x plus 2, my bad, with respect to x. Now, technically these are both u sub, but since du is just going to end up being a dx in both cases, I could just integrate them both as it is now. So what's going to end up happening is I'm going to get a 1/6, the natural log of the absolute value of x minus 4, minus 1/6, the natural log of the absolute value of x plus 2, evaluated whole thing from 0 to 1. Now, if you want, you can combine these. It's actually not a terrible thing to combine these into a single natural log. It's up to you. I'm just going to go ahead and plug in. So when I plug in, I'm going to get a 1/6. The natural log of 1 minus 4 would be a -3, but it's an absolute value. Minus 1/6. Oh, look, that's another natural log of 3. Well, that's convenient, right? Minus, now this is one of those times when you have to be careful because when you plug in 0, things don't go away. When I plug in 0, I'm going to get, in parentheses, the 1/6 natural log of 4 minus 1/6 the natural log of 2, right? And they don't go away. So the 1/6 natural log of 3 minus the 1/6 natural log of 3 does go away. But when I clean these guys up, I end up getting... so there's a couple ways to handle this. They actually do combine. You can either combine them by division and make this a 4/2, which would give you a natural log of 2, or you could actually recognize that the 4 is a 2 to the second and drop the power down in front. Either way, what ends up happening, if I clean this up here for a sec, however you choose to clean this up, right, you have a -1/6 the natural log of 4 plus a 1/6 the natural log of 2. You could, if you want, make this into a fraction, and that's fine. You could also recognize that this guy is actually a 2 to the second, so this is a -2/6 the natural log of 2 plus a 1/6 the natural log of 2, which gives you a -1/6 the natural log of 2. That's a totally okay answer. Another totally okay answer that some people might end up having is you might, instead of having it as a natural log of 2, you might end up with a 1/6 the natural log of 1/2, right? Because if you'd combined these as division, the 2 would be over the 4 and you'd get a 1/2. There are other totally acceptable answers, but those are probably the two most common. This is the one the AP had. As long as your answer is equivalent in log properties, it's not going to be marked wrong. All right, cool. Part C. Equals 1, find the value of the integral from 0 to 2 of f of x dx, or show that it diverges. So now, when we look at part C, we want k is equal to 1, which means f of x is going to become f of x equals 1 over x squared minus 2x plus 1. That's totally a perfect square trinomial. This is an x minus 1 quantity squared, or if you like it better, an x minus 1 to the -2nd, because that'll pay off when we're integrating in a little bit. Couple things to notice. First thing to notice here is that this is a vertical asymptote at x equals 1, which is important because we were asked to integrate from 0 to 2, which is why they mentioned diverging and why this is a BC question, not just an AB question. So if we picture what this graph looks like, just based on our kind of rough knowledge, there's a vertical asymptote at 1. So we have a graph that kind of looks like this, right? So the areas they're talking about are find this area, also find this area, because that's 0 to 2. The question is, do these ever converge close enough together to make it so that this thing has essentially a finite area and converges, or do they diverge? So in order to do this, we're going to call this point B instead of 1, because we can't actually reach 1, and we're going to have to use some limits. So what's going to happen is this first area is going to be the limit as B approaches 1 from the left of the integral from 0 to b of this f of x, right? This f of x, but we're integrating this guy, which won't be awful with respect to x, plus this other integral, so the limit as b approaches 1 from the right of the integral from b to 2 of that f of x dx, right? And in this f of x here, when we integrate this guy, right? When we integrate this x minus 1 to the -2nd, we're going to get a -1 over x minus 1. That's going to be my antiderivative, right? So my antiderivative, can't fit the word derivative on the edge of my board, but my antiderivative is going to be a -1 over this x minus 1. So essentially what's happening is I'm going to get a -1 over x minus 1 evaluated from 0 to b, limit as b approaches 1 from the left, plus the limit as b approaches 1 from the right, and then that same antiderivative, the -1 over the quantity x minus 1 from b to 2. Cool. So now it's just about plugging in and seeing if we get something infinite, in which case our answer is diverges, or finite, in which case the finite number is our answer. So when we plug in, we want the limit as b approaches 1 from the left, and I'll probably end up having to erase stuff and move up here in a sec, of -1 over b minus 1, and we'll deal with that in a sec, minus this -1 over a -1. So that's that first chunk. The second chunk is going to happen when I plug in -1 over 2 minus 1, so that's a 1, minus the limit as b approaches 1 from the positive of this -1 over x minus 1. -1 over b minus 1, I apologize. Cool. So, and that's the second bit. So now really what it's going to come down to is what end behavior happens. So we're going to go up here for a second. We're going to not talk about the graph of f, but we're going to talk about the graph of this. So I want you to be able to picture the graph of y equals -1 over x minus 1, which clearly has a vertical asymptote at -1, or I'm sorry, at x equals 1 rather, right? But if you picture this, unlike the one that we just had that was squared, so both branches were positive, this graph is going to have a vertical asymptote at 1, and then a horizontal asymptote at 0, because you can see that the limit as x approaches infinity would be 0, right? So those are my asymptotes. And the question is just, what's the graph going to look like? Well, you can either know, which would be dope and super awesome, that, like, for instance, a 1 over x graph hits quadrants 3 and 1. And that's great if you know that. Super dope. It's kind of logical that it does, because when your x coordinates are positive, these would all be positive outputs, 1 over a positive, right? If you know that that's what a regular reciprocal graph does, you can see that one that has a negative reciprocal is going to hit the opposite quadrants. It's going to look like this and like this. Now, the reason that's relevant is that this is asking you what's happening in this graph, the graph I just drew, as I approach from the left. Well, as I approach from the left, this is going to a positive infinity. This one, on the other hand, is asking you what's happening as I approach from the right, where I'm clearly going to a negative infinity. So if you write these values out, like if we understand that that's what's happening, then what this expression actually says, right? What this expression actually says, sorry, my black marker's kind of dying, is positive infinity, because as we approach -1 on this graph, as we approach -1 from the left, we get a positive infinity, right? This guy ends up being a -1, cool. This guy ends up being another -1, cool. That's not really what's concerning me. And then this guy ends up being minus a negative infinity, which is totally plus another infinity. So what ends up happening is this -2 is pretty much irrelevant, right? So it doesn't really matter to me that I have that -2 there, because it's 2 times infinity minus a 2. That's like Bill Gates accidentally dropping $2. Oh, Elon Musk dropped $2? He doesn't care. Oh, you know, it's cool, not a big deal if Bezos drops $2. So this is definitely an infinite value. So this diverges, right? Because this value diverges. These are both infinities, they diverge. Cool?